Okay, welcome to ICNRG. It's Tuesday. So this is IETF ICNRG, Information-Centric Networking. If that's not what you want to see, you're in the wrong room.
No, you're still in the right room.
Don't close the doors. My co-chairs are Börje Ullmann, Dave Oran, and I'm Dirk Kutscher. The IETF IPR policy, in short, inform us if anything you see here or you present or discuss is related to IPR, so notify us in a timely manner. This is our usual infrastructure, so we have a mailing list. We normally keep track of all our activities on a wiki page. Is Marie-José taking notes today? And is she doing the notes? Or?
We did have a note taker, right?
No, that. Okay, this is copy paste from.
So that means we still need a note taker.
Note taker, please. We can't get started without one. It's not a big job.
So we got great help from Marie-José on Sunday, but we cannot ask you to do it again. So please, somebody else. Again, thank you so much.
Do we have to give you poutine or? All right, well, then I promise I won't make you eat poutine. Okay. All right, excellent. Thank you, Marie-José.
Okay. That's really helpful. So quick overview of today's meeting. So we give you some updates on, say, our standing activities, documents we are moving forward. I'll talk also a little bit about the Sunday meeting, and then Eve is going to give us an update on the Intel NSF sponsored ICN Wireless Edge networking program. And so we thought that we could discuss mobility management a bit today. So recently there have been different proposals as to how to manage mobility in ICN, like producer mobility, for example, but also as to how could this fit into existing frameworks. So, for example, ongoing 5G standardization and so on. And so Luca has kindly volunteered to give this some thoughts and also try to generate some discussion here in the room. So if you're working on this and you have some ideas and you haven't really followed up with Luca, please start thinking now, and so we can have a good discussion. And then we have a block of different draft updates. So we'll come to this then later in the session. And in the end, we would like to kind of give you some ideas how we want to continue working next meetings and so on. Quick summary of the Sunday meeting. So we had again a really interesting Sunday, like full day meeting with an extended break that made our French participants happy. So Yannis talked about mobile data repositories at the edge. So this, maybe you could describe this as thinking about, data logistics, useful services that ICN could provide. Thinking about, say, use cases where you generate tons of data in edge, for example, in an autonomous car, and you need to store this, but also make this available at some point. How could ICN help? So Yves and Martin and Marie-José presented ideas for video distribution. So that's a local company here in Montreal that is trying to change the model of video distribution and considering to use ICN for that. That's also highly exciting. And Luca gave us an update about the activities on HICN and specifically the concept for transport layer and socket API that was designed to kind of enable applications to work with an ICN network, but also giving some thoughts on really high performance. So if you haven't been at that meeting, I encourage you to check out the slides, which had some really interesting comparison, comparing their HICN stack with a like traditional TCP/IP stack. So it's really good results. And that also included a demo, so WebRTC over HICN. So in general, Sunday was really cool because we actually had 3 different demos at that meeting. So all the material is online. And then we also talked about a framework for mobility support. So ITAC was doing that. And so ideas for so-called stateless forwarding in ICN. In the second part of the meeting, we had a blog on video augmented reality. So Cedric is working on a draft in this field. And then Tagami-san had a live demo for 360-degree video, so using ICN, so leveraging the fact that if you have, say, multiple users so watching the same video, you can tile the video and then benefit from caching the individual tiles and achieving performance or efficiency benefits. And that was demoed live during the meeting and was also pretty cool. And so connected to that, so Yves had some ideas on, maybe smart city environment where we have many cameras and you want to kind of process this data, maybe generate some insights, basically moving data and say processing results upstream. So it's also kind of related a little bit to Yannis's first presentation. And so Jungha also gave us a demo on like seamless producer mobility that was leveraging the name resolution system that they developed at Etri. So it was a live video streaming example, and which also worked really well. And so finally, so we had one presentation by Milan and Anil about ideas for supporting QoS in ICN. And if you have been around for some time, you probably remember that we had like different proposals that had been brought to the group. So what you could do in ICN. So some things like leveraging these like the more explicit naming, maybe trying to adopt concepts from IP. And so this led to a, I think, good initial discussion. So what are the possibilities that ICN provide to provide QoS, but also maybe to arrive at slightly different, maybe more elegant, more efficient solutions for that. So there seemed to be quite some interest in that. And also I think so Dave posted a draft on a flow label idea on the mailing list. So that could be something as a kind of topic that we could like to discuss more in the future. So just as a heads up, if you're interested in QoS performance management kind of topics, this could be for you. Okay. Yeah.
Keep your voice going. So I'll quickly go through the status of official status from the points of view of the chairs of various work items and drafts that we have. I'll try to go through this really fast. A number of the drafts that are active, we're going to have explicit updates from the authors at the end of the session. But let me just go quickly through, because some of these we will not be discussing actively at the meeting. So the first is the 2 CCNX protocol documents, which are destined for experimental RFC status, have passed IRSG review. We got some relatively simple comments back. Had another sort of pass through the folks in the RG. There have been updates posted of those 2, and this is now is Allison in the room? No. Okay. Well, absent Allison in the room, it's in her hands to do the final IRSG poll on those 2 documents. And assuming that goes well, those will move directly to RFC publication once that poll completes. This has been a very long process, obviously, and I think people should be very pleased with the results. We may have 2 actual protocol document or experimental RFCs out of the group for the first time in a long time. The second is Flick, which, as some people know, using manifests is fairly important as a way to structure data for CCN applications. And that document's been worked on by the 2 authors, Christian Schuden and Chris Wood, over some period of time, but it's kind of stalled. And Chris has a relatively new job. He's not going to have any time to work on it. Christian does what he can, but he's also very, very busy. It would be very nice if there's some folks in the working group who'd like to step up and help work on this and maybe take over co-authorship of that draft. We really need to move it forward because the actual extant implementations that are out there in open source actually implement Flick. So we have implementation ahead of spec in that sense. Next, another finished draft is our disaster scenarios draft. That went to IRSG poll, came back with 1 set of very nice comments from Vincent Roca, and I'm waiting for comments from 2 other IRSG members who said they wanted to look at it. Once we have that, we'll do another spin of that, and hopefully very rapidly that will get through the knothole back through IRSG poll and to publication as an informational RFC. Pardon? Oh, yes, and Marie-José sent comments. Thank you. I only thought of right, yes, Marie-José sent comments. I'm still waiting for comments from, I think, Spencer Dawkins. We have some recently adopted RG documents that have been adopted either at the last meeting or since the last meeting. The first is a terminology document, which, again, it has sort of stalled. We don't have an update at this meeting. Hopefully, we'll be able to move that forward in the interregnum between this meeting and the next one. And a document that's been presented a number of times, and we'll have another update today, on deployment considerations for ICN. And we're going to be looking at this meeting and then sort of for confirmation in the mailing list as to whether we believe this is ready for RG last call for sending on to publication and IRSG review. A few other drafts that we'll be hearing about. The native deployment draft on LTE. We'll have, I think, an update on that. And design considerations for ICN over IoT, which there'll be mailing lists. There's mailing list stuff on updates for that. Some new stuff. Last meeting was introduced a mobility scheme for CCN style ICN called MapMe. It got submitted as an RG document, but it isn't an RG document, so we have a naming problem there. But at some point, we would like to look at whether the RG wants to adopt this as a work item. We're going to hold off a little while on that because there's IPR on that, and we want to see the IPR declaration from Cisco before we move too far with that draft. It's submitted? Oh, okay. All right. So yes. So I would like we can. I don't know that we'll talk about it here, but we should have a discussion on the mailing list about whether this should be adopted as an RG document. Technically, it's in pretty good shape. There's another one called CC Info. I'll be talking. Hitoshi Aseda, the author, one of the authors, isn't here. I'll be talking about that briefly during the draft update session. We have a document on considerations for applying ICN for edge computing. So that's sort of the status of everything that's sort of like bubbling in the pot. We're pretty, I think, happy at chairs at the level of work product that's coming out, and I hope we can continue that way. So let's go on to today's presentations, and I think Eve is first up.
Maybe I'll just take this out. Can I take it out?
Luckily, that doesn't operate as an invisible fence.
What does not help? Okay. Hi, I'm Eve Schuler. I'm from Intel, and I am on the board of advisors, as is Dave Aran and Christian Chuden, as well as several other people from Intel, as well as another external board of advisors member from University of Michigan. But essentially, I'm here to tell you it's a year since the last time I was here. We've had a year of research on a program that's jointly funded by Intel and the National Science Foundation, which is one of the key funding agencies for computer science in the United States. And internal to Intel, there are a couple people in our wireless lab who are the program, the PI and the program managers in our university research office. And of course, these are our partners at NSF. You probably recognize Darlene's name and maybe even Monisha. Just to give you the high overview here, the high level overview, because some of you may not have heard the previous presentations. This is a $6.5 million program, which runs for 3 years. And we decided that there were 3 teams of universities that we wanted to fund. And clearly, ICN-WEN stands for Information-Centric Networking in Wireless Edge Networks. So clearly the focus is going to be on wireless edge networks. And what was interesting to us about that venue was really if you look at what's going on with 5G, the call for support for ultra low latency and massive IoT applications. And we want our researchers to look at least 3 aspects of what we mean when we say wireless networks: the endpoint devices, the infrastructure and architecture, as well as the wireless data security and privacy. And I don't know if this is aspirational or not, but we did put into the call that, and there were many who said that this was also interesting to them, for clean slate design. And as yet, people are sort of right now, some of the implementations that exist are not clean slate, but we're hoping in 3 years that more will be. Our research goals, if you put this into this slide deck into slide presentation mode, there's a link there to the actual solicitation, which is quite interesting. But it asks for, as you could well imagine, a more integrated approach for ICN and wireless networks. And what are some of the fundamental changes that will occur because of that? And the age-old issue that, how do we compare ICN to not ICN, and is it to IP or is it to something else? But can we quantify as well as qualify the benefits of an ICN-enabled network? And to do this by anchoring this work in realistic implementations and deployments. So that was the goal. Last time I was here, I think it was right after we had announced the awardees, and this is about a year. In the interim, we decided we also got enticed to do a little bit more funding for another team that I'll talk to you about. And we just had our first year review, and these slides I make, I can't claim. I'm going to be talking about other people's work. I'm using their slides or condensations of their slides. It's going to be a whirlwind, high-level overview just to give you the shape of the various programs and their objectives, some of the results they've had in the interim. And I will try to do them justice, but no doubt I will point you at them for follow-up. And that's really the point here is how do we, first off, having a program like this enabled us to bring some new people into the community who have completely different perspectives, because this is about co-design and cross-layer kinds of work. But however, they are, so some of these people are not really schooled in what's going on in the IETF, and they live in other communities and certainly the wireless community through GPP and elsewhere. So I think some of the dialogue I'd like to hear about is really how do I connect them to people who are doing similar work in this environment and how to get them acculturated around the standards in the IETF. These are the three main projects. We won't sit on this page too long because I'm going to go into great detail in a moment. But I mentioned that in addition to the three teams, no, you'll get that information later. In addition, we have a team that is out of Stanford and Northeastern University in Boston. That is a really interesting pairing of Edmund Ye and Andrea Goldsmith. And as you can imagine, if you know their work, it focuses on the joint optimization of routing and caching in heterogeneous wireless networks. And we were quite interested in this because it's a more theoretical piece of work, but it also stems from the fact that they're involved in some of the state-of-the-art joint caching routing algorithms that they're the ones to beat in the wired world, both with fixed topologies and dynamic topologies, and through extension, they're hoping to extend these algorithms to the wireless realm as well. And when I say routing, I'm talking really about routing at the internetworking layer and above. I'm talking about the wireless, interacting with the routing and caching that ICN might have to offer. So that hasn't really been going long enough for me to report out on details, except to say that they're working away. Okay, I think we do have Leisha here in the audience. So hopefully if you have more detailed questions, she is here afterwards for you to touch base with. She is part of, and she is the lead PI on a program called ICN-enabled secure edge networking with augmented reality. And that's because the application that they've chosen to anchor their work, it's not the end result, it's just to drive the research, is augmented reality, and thus they call their project the ICER project. And you'd probably recognize many of these names. It includes University of New Mexico, where Jay Misra is, and it includes Alex, who's now at Florida International University, and the others are all at UCLA. Now, they are trying to drive research along multiple dimensions, and fundamentally it's all about naming. And in fact, one of the most interesting conversations that we had, for me anyway, at the meeting, the face-to-face, was all about there is this skill or this art to the design of naming and namespaces, and what is it, and how do we school people in it, and are there best known methods around it? And so I think we should come back to that. Maybe do we need a workshop around that, etc. So there's a big discussion going around around that. Acceleration as a service, meaning at the hardware level, FPGA, what kinds of networking algorithms do we accelerate? Interest in local resource discovery at the edge, security, privacy, and trust. And clearly, how does the upper layer mingle with the lower layer? But how do we interconnect all these disparate pieces? Part of the objective of this program was to bring together people who live in adjacent areas and get them to actually work together, not only on these teams that got the funding, but across teams. So we're still hoping that's going to happen, and we're just starting to see the fruits of that. What have they done in this first year? I would say the thing that impressed the folks at Intel the most was really that they have a working implementation and prototype of an end-to-end augmented reality application. Oh, there's Leisha. She can hear me talk about our work now. Anyway, so we were very impressed with that. And that has driven a lot of understanding about what are the requirements, what are the kinds of workloads encounters, what are the security issues. And it has led them to really take a step back and re-examination of libraries that already existed in their toolkit. Things like their common name library, where how do you expose meta information across different layers? What is the naming going to touch? And also some of their real-time library work. So as I said, this is going to be a whirlwind. I'm not going to go into tremendous depth unless you ask me questions afterwards, but I just want to give you a feel for the breadth of exploration here. I spoke about acceleration. Oh, and by the way, these are, as I said, these are their slides that I've sort of adopted for me to tell this narrative. They started looking at FPH for network compression, and some of their results have led to 4.7 times better energy efficiency than, I'll just state, a leading GPU that is out there. And to us, again, quite interesting, if ICN is being used for service distribution, then maybe we put those algorithms into our FPGAs or even for network processing, and that is an interesting result to us. For security, as I said, Jay Misra has been looking at trust frameworks. The augmented reality work is meant to be supporting a campus environment, but also at the same time supporting the what ifs of an emergency or disaster scenario. And so it's very interesting to try to understand what are the security implications for the different kinds of actors who might need or want access to the infrastructure, and the day-to-day life of universities around faculty, student visitors, but in an emergency scenario, there are additional members. You'll see in the write-up of the publications, there's quite a few quite interesting mechanisms for access control, and we were pleased to hear that Jay and other colleagues are looking at some of the hard issues around the revocation of access control, and additionally that, of course, leveraging some of the existing trust schema work that and other things that already exist in the tool suite. So another interesting result, at least for me, having been that I haven't had my hands in the wireless co-design issues, is just how difficult some of these boxes are, if you will. They're black boxes, and kind of getting access to them in order to adopt them and amend them was an interesting sort of challenge that multiple teams had. I found it quite interesting that the preliminary experiments allowed them to be able to characterize the workloads for augmented reality and virtual reality, and to point out specifically what are therefore some of the deficiencies in the 4G world. And there's an interesting paper from Sigmetrics this year. I think I will simply state that the intent of us selecting these different teams, and you'll see two of the teams are quite complementary. The UCLA anchored team and the next team that I'll talk about, which is I call our Midwestern group of universities. They're really nicely complementary because they're both using NDN. And whereas the expertise in the NDN team comes from having been, leading members of the NSF FIA program in the US, so at the routing layer, that's where they sort of started out life. This other team was in the wireless realm. So the kinds of cross-pollination for the co-design work is very interesting to us, given those multiple perspectives. I also was intrigued with this. We talk a lot about quality of service and also this, comparison with other, with non-ICN kinds of frameworks. And I really liked the fact that this team had taken the time to talk about what they were trying to measure in their comparison. And here you can see that these are qualitative measures, programmability, ease of use, and so forth, that we need to develop some metrics around, because I do think that that's really where ICN shines. That's my personal opinion. And then also they went to the trouble to say, what are their lessons learned? On the one hand, there's, naming has two sides of the same coin. On the one hand, it enables networking and storage and processing all to sort of come together and into a cohesive design. On the other, it can be very difficult to integrate all these pieces together because they all have to speak naming. So I found that an interesting result. There, obviously design principles, as I said before, kind of what are the best known methods for doing this kind of work, and then that the application-driven architecture development has been instrumental in teasing out gaps that need addressing and the challenges. And I would second that. I also think that's important. I don't know if you can all read this. This is a much smaller font, but I deliberately put the publication lists in here so that when you download the slides that you can peruse them, because that's really where I wasn't really at liberty to talk about the work that is underway. I really wanted to just talk about the public work. Okay. Lots of papers. Oh, and as I said, there's some very interesting ones. They span the gamut because we're really trying to get the architectural breadth. Okay, second team, they call themselves the SPLICE team for Secure, Predictive, Low Latency, Information-Centric Edge for next generation wireless networks. And you can see there's quite an interesting crop of schools here, Texas A&M, otherwise TAMU, Ohio State, UIUC, Purdue, and Washington University in St. Louis, or WUSL. And I would say that what anchors their work has been this search for how do you assess quality of service, and furthermore, how do you really truly embed ICN in the wireless edge network? As I said, this was a strong competency in this team. And when I say, the wireless edge network, they are looking to, how can they exploit, Dirk was talking a little earlier about one of the demos that we had seen, what kinds of, in that wireless local edge, what kinds of commonality is there in the data and the usage patterns and so forth that we could leverage multicast and caching and wireless? How do those things combine together and exploit predictability, etc. Okay. Again, how am I doing for time? Okay. This is the picture they like to use. You can see it starts at I don't know if you can see the fonts, but, up here is quality of service, applications, user privacy. Here's NDN right in the center here. Down below, they've put caching, but then note it has interactions with coding, which is a wireless, wireless coding, as well as security. So security and privacy sort of straddle these layers, and wireless control mechanisms, as well as power constraints and interference constraints, which makes it quite interesting. And these are, again, some of their objectives. There's a lot of wonderful wireless caching interaction in terms of optimizations, joint optimization. And I think I will, one thing I should point out is that in contrast to the UCLA team that is looking at augmented reality, this team is specifically looking at virtual reality. And, So what do we mean by virtual reality? So first off, I've already told you they're a wireless team. And so it's not just conventional, wireless networks. It's also all the wireless gadgetry that they'd like to cut the cords from. So if you're doing virtual reality, your network needs to include the components that are typically part of the rendering loop. And that includes a headset, which, as you can see here, it tracks your pose, the controller, which tracks your gestures, and a renderer for rendering the high resolution VR content. And you can see the kinds of responsiveness that they are aiming for, and which is, less than 20 milliseconds, and frames per second of greater than 60, and they're trying to be untethered. And so that's pretty hard to do these days, certainly when we think about NDN and 5G, which is why I think it's a great context for pushing the envelope. Now, they had some interesting work already on single-player VR applications on mobile, and that they published last year. And what they did was they realized that they couldn't really do all the processing in the places that they wanted, and they needed to have a split architecture. And this starts to wend its way into why it is that there's these discussions around edge computing. And so for they broke the foreground processing to stay local, and the things that they could send across the network, they sent across the network to somewhere else that didn't need the quick updates. And so that was some interesting work from last year. But then they decided, well, we need to support multiplayer games, but that, of course, requires n times the amount of bandwidth. And although they don't have their published results as yet, I can say sort of vaguely that what they have done is that they're now prototyping on their testbed some pretty novel techniques that try to leverage the commonality among the players in these multiplayer games. And they found things like having looked at about 6 different kinds of multiplayer games, whether they were shoot 'em up games or competition sports games, or they had a whole variety of categories that I should be more familiar with because I have 2 sons who are addicted to these things, but or myself sometimes looking on. But nonetheless, for these kinds of games where you've got groups of multiplayers in the same location, that about 70% of the frames have commonality by some definition of commonality. And so that's what they are trying to exploit here. And that they also had some very interesting results about how do you meet the accuracy requirements that are down to like millimeter accuracy levels, which again, very small, and how do you get there? And so they employed some inertial measurement using existing gyros, and that's what IMU-based methods stand for, and that they're in the process of combining that with other methods to reduce their the error rates further. And that's really important for the realism and the avoidance of people not feeling well when they play VR applications. There's a student who's about to graduate, who's Patrick Crowley's student, Hila Ben Abraham, who's been looking at specifically how do you enable NDN in this context, enabling VR over NDM. And as you can imagine, these AR and VR applications have some requirements that we don't immediately meet. They are event-driven applications, and they rely on quick delivery of prediction and push notifications. And of course, NDN and some of the other code bases are pull infrastructure. They support pull infrastructure. So her innovation was to create what she calls an information-centric transport, she and her colleagues. And there's a link here to a paper which I believe has now been accepted for publication. And it's about mechanisms that allow applications to receive push notifications and notifications in general. So that's an interesting abstraction that, again, if you look at what this says here, her aim was not so much the push notifications. It was twofold. It's the push notifications, but also to simplify the applications by allowing them to be agnostic to the networking mechanisms and characteristics, and it just stays in the information plane. So there's some interesting results there. as I stated earlier, this team really excels. I don't know if Ihong is still in the audience, but he was here for the first ICNRG meeting, and he's part of this team, and he's part of the team that is looking at multicast and reconfigurable Macs and so forth. And so they were looking at the popularity of content, and so they have developed a new proactive multicasting algorithm. And as I stated a little earlier, I want to point at this because I'm reading it. There's so much that I don't know as you report on other people's work, but you can see that they have some of the key insights is that they've reduced the delay even with small caches and misaligned content, and they have what they call moving window codes that have also improved the performance over traditional rateless codes and with very little overhead. I also was intrigued by their, as I said, they've done some Mac scheduling because, again, they're looking at supporting applications that have really low latency or can have low latency guarantees. And so they have developed, and there's a nice paper on processor-supported ultra-low latency scheduling. This is another case where they decided, how do we split the processing between the FPGA and the main CPU, and this relates in this case to the Mac. On the security front, they've been very busy as well. They are leading the charge on trying to understand how blockchain might be incorporated into PKI. And they have some findings that state that it's significantly reduced both the cost and time at adding new certificates at the server and the IoT device. And they also have submitted, they have a paper appearing that is an approach for privacy preserving attribute-based access control for NDN. And finally, one of the pieces of work that I found quite interesting is that they're trying to look at trust models and vulnerabilities for different protocols, and they were looking at vulnerability discovery in 4G, and they've now cast their net a little farther to look at 5G, and they've also cast their net to do an analysis of NDN. So, that's what's on the horizon for them, but they are at least have some results in the 4G scenario, and this LTE inspector is a tool that they've created. And they also have created some algorithms to identify under what circumstances you can figure out that there are fake base stations out there. So you can see the work is pretty varied. As I stated earlier, when I was talking about the UCLA team, we found it really wonderful that there was a real application that had been deployed and was being used and is end-to-end. In this case, this team really, they come from a different community. They didn't already have a testbed up and running. They didn't even have a NDN or ICN code base. So for them, they have been doing their experiments in sort of, in a sort of disparate fashion. And what's coming down the pipe right now is they've been hard at task trying to design a spliced testbed. And so that's launching, and so that they will have a venue where they can more methodologically, systematically do their experimentation, and for all these schools to come together and rally around this testbed. So that's what's on the list there. They are prolific. They are, as I stated, Ihong was here earlier, and you can see he's doing all this optimal rate control. He's an optimization person, scheduling decentralized medium access protocol for real-time wireless ad hoc networks with unreliable transmissions, all sorts of wonderful work to explore here. I hope you will take a moment to peruse these. And again, kind of all over the place. Best Paper Award, you should certainly read that one. And some NDN related work towards the bottom, and the security towards the bottom. Okay, how am I doing for time now? Okay, so I have 5 more minutes. How's that? Perfect. And that's a perfect name for 5 more minutes. Lightspeed networking, right? Refactoring the wireless network stack to dramatically reduce information response time. And this is primarily an interaction between University of Massachusetts and University of Wisconsin-Madison. And what I like about this team is that, first off, their approach to ICN is they come out of the mobility first community. They have tremendous background in service architectures, edge computing. Their idea of information centrism is, there was a big debate, and actually it is a question, like, what constitutes information centrism, and how do you define it, and how do you know that something is information centric? And some of it comes from the fact that they have a really disparate worldview, well, a different worldview than, say, the NDN and CCNs of the world. And I should note that with the previous work where I said that they are very focused on quality of service, one of the most interesting conversations was about this opportunity to, if we really are going to do quality of service and quality of experience, that we want to expose more information, more, whether it's names or manifests or meta information across the layers, because how the heck are you going to do those things unless you really expose more information? And so that was another very interesting discussion at the event itself. These colored items are topics that I will talk about. Since I only have 5 minutes, I will state that you can see they're big. Well, I'll get there in a second. Let me just tell you what LSN is in a nutshell. It's trying to really leverage the edge cloud, drive down the information response time, and that's where the light speed comes from. They want to go from milliseconds to microseconds, drive down power consumption, milliwatts to microwatts, and improve trustworthiness, whatever that means in this context. And I would say that because they come out of the mobility first community, and because that community thinks of the name as the global, unique identifier, the GUID, that it's less about a file name and therefore less about a piece of content that looks like a file, and is an identifier that can be attached to all sorts of things. And I think that that's more aligned with some of the discussions going on in interoperability for the Internet of Things. And so those GUIDs can be attached to things that are interfaces, devices, services, content, groups of names, and so forth. And that this is a very AP-centric kind of architecture, because it's really about, as things move around, as people move around, how do you move the services to follow the people? How do you move that edge cloud? How does that mobile edge cloud follow around the application or the person attached to that application? So it's a slightly different mental model. And so this is a picture of their service dispersion architecture. And just what's meant to be implied here is that, when we think of data centers, then they're going to be, regional data centers and nano data centers and micro data centers and our edge data centers. We are data centers. And sort of how does all of that stuff get orchestrated, and, by the way, have an information-centric infrastructure to support that? So that's really where their focus is. So their results are, and I just have one more slide after this, is they have built now a feasibility and proof of concept of what they're calling Gigapaxos, which is their service dispersibility framework and implementation. They also, interestingly, I think this goes back to our conversation about what is information centrism, and how do you even begin to compare the different models. They have a paper in Infocom this year about ICN architectural comparisons, so I would encourage folks to look at that, and specifically for mobility support. They also, at the lower layers of the network, they're looking at radio polymorphism, because, again, these applications have such a wide range of requirements. How does any radio handle that? And so they've been looking at complete hardware design of a polymorphic, oops, sorry, I hit the wrong button. Okay. No, one more. A polymorphic radio to switch between active and passive transmission and reception, and with a 5 to 10 time power improvement. And they're looking to incorporate that into an edge cloud-based learning environment. One last slide. They have some quite interesting work on private information retrieval, meaning if you ask for content over the network of a server, how does the server not know that you know what you've asked for? And so these are some results on that front. And additionally, they are in the throes of how to limit personal information or private information leakage in APs. And then how do you roll all of this up into some use cases? The UCLA team is focused on augmented reality. The Splice team is, and I should not call it the UCLA team, it's the ICER team is augmented reality. The second team was virtual reality, and this team has really has promised to deliver an application in the vehicular space, and has also done some work in the smart home. And then finally, some of the early pictures that I sort of raced through at the beginning, but you can peruse at your leisure, really talks about this semantic control plane and what do you use it for? And this goes back to the idea of what's the value of the data? How do you even know what the value is? How do you share semantic information and so forth? And this goes back to the metadata discussion. And so they've created this control plane, and they're using it for their dispersibility infrastructure so that they understand, oh, there are resources over here, and these are their capabilities, and this is how I can map what my job looks like to those things over there, and this is why I might migrate it. And all of this done using a mobility first inspired infrastructure. So I think that's it. They too have a wide range of publications that you might enjoy. And I think I did touch on all of these interesting questions that I think this community should take up at some point, because I think it's relevant to whether or not it's going on in the ICN1 program or some of our design discussions as well. Thank you for letting me talk about other people's work. I hope it was somewhat intelligible. And I would encourage you to download the slides and have a look at the publication list. And I'd be happy to make introductions to team members or team leads and talk further with you.
Thanks for the great summary. Any questions or maybe additions? Right.
Yuanfei Zhang, Tencent. Interesting work. So can you go back to the acceleration page? Maybe page 10 or...
Oh, it might have been even...
It should be the first part.
Yeah, I think it was in the oh, I can look down here. Yeah, look at that. Did I go back past it? Oh, there it was. Oh, we have Lishi here too. She can help us with this.
Previous?
One more?
No.
No, hang on. There it is.
And no.
Acceleration workload. Oh, there was an FPGA. Here it is. Here it is.
Exactly.
There you go.
So I'm quite interested in the reason that the FPGA is better than the GPU in their energy efficiency. So can you see a little bit more on the detail?
I really can't, but I think maybe Lisha can.
I'd like to know exactly what your question is. The basic idea is the following. That is, for augmented reality, there are all kinds of different processing requirements. And therefore, you do not know exactly. Can you get closer to the mic? Yeah, you do not. You may not know exactly what the functionality to put in. So FPGA gives you the flexibility. You can actually download the FPGA code in sub-seconds. So what we put into the AP is just the chips. And therefore, depending on the application requirement, you can download the FPGA code already compiled and then do the execution there. Actually, the power of this is not so much of, okay, you can download the FPGA code. The power is really name the data. What is that piece of code? That's a piece of named data. You know, the AP knows, okay, I got this a functional requirement. You code it into the name what the function is, so that the execution in the running in the AP just download that code, and you can run it. I definitely don't want to waste everyone's time here to elaborate further details, but we should chat offline how NDN really realized this edge computing. You can, like here said somewhere, to say that you can integrate the storage, processing, and networking all together.
Oh yeah, I think I had it right here. Yeah, it was your takeaways. Yeah, lessons learned.
Okay, a second question.
Okay.
On the second part,
Mm-hmm.
so for the untethered.
Oh, untethered.
Yeah, yes. So I'm not quite sure about the rationale. So to realize the untethered VR, I think the biggest enabler is the 5G network to enable a large volume traffic as well as low latency. And I'm not sure how about the NDN can benefit to the to this effect. I mean, how much degree does it affect the untethered VR?
Well, I think that at least my understanding of the intersection of 5G and, I see other people who understand this too, that sort of where does 5G and NDN, and it's really the wireless. So 5G I'm going to use as a bucket for wireless and mobile communication, and then the caching. I think there was a statement here, maybe in this about predictive caching and coding and learning, sort of these kinds of things together are perfect for co-design. And so back to your point about 5G, my understanding is that it's sort of aspirational for 5G to want to have low latency to the levels that are needed for this application, which is less than 5 milliseconds or less than 1 millisecond. And certainly for factory kind of context, it can be less than a millisecond. And so at least I know some researchers, and I couldn't swear that this is what's motivating the Splice team, but some researchers are looking for any other ways to extract either one, not sending redundant information over the network, caching things closer, all those kinds of things that might shave off just a little bit more time from the latency that would be encountered by traffic on the network. So it's a little bit subtle, but at least that's part of the story. I can see Leisha's behind you. She might have some additional thoughts.
What you said is all great. I just add one more. Look at the predictive caching. In the 5G, after all, it's a channel. You don't really directly address the contents. To do this kind of games, you actually need to name the contents. That's where NDN comes in.
Oh, and the predictive caching is, of course, needing it, sending it before you know for certain that you need it.
What I mean is that to achieve the end-to-end, maybe 20 milliseconds delay, the proactive caching doesn't have so much degree effect on that. So
there's no such thing called the end-to-end. What is the end? The end is the consumer. The consumer, from request to data arrival. That's what the delay is measured.
Well,
it's not really
right.
Where the data has to come from exactly. As long as it's the data needed, you achieve the goal.
Looks like Luca has a question as well.
A very short one. I didn't see anywhere mentioning the NDN testbed.
This is good.
Or funding to the NDN testbed, or if there's any relationship between all this work and projects and the NDN testbed, because it's a pretty impressive testbed worldwide.
It is, and so the WUSL people are part of the Midwestern. The Splice team does include our friends at WUSL, and we know where Patrick is these days, but still there's a pretty sizable team still that's part of that, and they maintain the NDN testbed. But that Indian testbed isn't necessarily focused on wireless. Wait, don't you guys have a private conversation? Come share with us.
No, I was going to say that this project, I mean, this whole program with 2 projects on NDN, doesn't really explicitly fund the NDN testbed.
No, we don't.
I was looking to look at to see if Cisco would contribute.
I love it. I love it. But it's a good question, I think. But we could let's follow up on that, because that's a very interesting topic of how do we leverage the already existing test beds, and how do we share some of the code base for testing using different sorts of applications, because as you can see, that's what's driving some of the pushing the envelope. Thank you for letting me have so much time.
Thank you very much, Eve, for that's really great summary. Okay, well, let's move on and talk about mobility.
Need a dongle?
Do you want to use the clicker? Ah, perfect. Yes, PDF. From the PDF.
Hi everyone. So this is a slide deck that we put together. That one.
Mm-hmm.
Okay. For an
No out
Italian,
of the box thinking.
for an Italian, it's going to be very difficult to stay here.
Yes.
Okay, I'll try. So the slide deck is trying to provide feedback about some of the work that's been done in the space of 5G standardization. So this is essentially to provide feedback to the ICN research group, but also to try to stimulate more research work in this space, something that we can bring in the first place into the ICNRG, and then try to push into other places like DMM working group, or in other places like 3GPP as well. So as you may know, we discussed about this in other meetings. CD4 is a study item that is taking care about, especially right now, about different user plane solutions for 5G. And what Eve just presented is actually this different kind of applications that you want to see in 5G. So it's really it's critical for 5G design and standardization work to provide support for those kind of applications. So we're talking about very low latency, high bandwidth at the same time. So the requirements are going to are already very difficult to satisfy. And in this research group, I think we can provide support and solutions for some of the use cases that 5G is trying to solve in a very different way with respect to other solutions. So, so it is important that this research group is aware about the different solutions that are being considered in terms of user plane solutions, which is something that CD4 is going to start to study in the following, starting from now, basically. So there's been a meeting this morning in the DMM working group discussing the different solutions, but also the requirements that CD4 is looking for future standardization, and the focus is essentially on trying to replace anchored solutions, both in the user and control plane, essentially GTP protocol, with other solutions that can support the kind of applications that Eva presented before. So there are several protocols that have been presented this morning at the DMM working group. Some of those are SRv6, Lisp is another one, ILA, so as another loc-ID solutions, and HICN is the one that we presented, which is the, so for those who are familiar with HICN, is an IPv6 implementation of CCN as specified in the draft that are being worked out in this research group, so the CCNX draft. And so it would be very useful to have those drafts in RFC publications as soon as possible. So hopefully in the following months, I hope.
Don't look at us. It depends on contributions.
I'm saying it would be very nice to because that would be a very good achievement for the research group as a whole.
Yeah.
I just had one comment. I mean, I was remotely participating in the DMM thing. So what I understand is that they're mostly trying to solve a traffic steering problem, a traffic engineering problem, not a mobility problem. Because primarily what you do between N9s are simply saying, okay, how do I take the traffic between two UPFs? I towards the last, I saw that they were trying to do something at the N3 interface, but that doesn't seem to be the priority. I mean,
that's right. That's right.
So.
Currently, they are focusing the N9 interface. We're going to talk about that in a second. But that is an opportunity. It's a starting point. So I think that as a research group, we should look at that as an opportunity to start showing the benefits of replacing GDP and the way GDP is used in that interface as a start. To also show how, and this is actually what other solutions are also trying to show, how that kind of benefits can also be pushed in other interfaces like N3 and others.
Yes, I understand, but because you said mobility management, I think that's not the focus. I don't know the wordings, what CT4 does, but from
it's all mobility management. I mean, the N9 is about mobility management. It's used to anchor.
But you are still going from the G node B to the first VPF on a tunnel, unless that is where you have to handle mobility.
Every single interface is about mobility management. The question is up to how many anchors you keep in your end-to-end communication. So if you say the N9 is not about mobility management, try to put it down. You'll see what happens.
I mean, you have to anyway handle, because you have to handle this network part too. Anyways, what I'm trying to say is that it seems to be trying to solve a more slicing problem than a mobility management. That's what I got a feeling reading the draft.
I think they're kind of orthogonal problems, slicing.
No, slicing in the sense like if you can have multiple slices and then you can give different QoS and traffic management treatment to how different traffic. So I thought that was the focus solving the N9 problem. But as you said, probably you can leverage some of that towards solving a mobility kind of entire mobility problem. But focus seems to be right now more.
The question about let's go directly to the N9. So the question is, for those who are not familiar with the 5G terminology, so basically the N9 is the link between the SGW and PGW for using 4G-like EPC terminology.
Yeah.
So that link is something that is used not much today because they're typically collocated. So if you try to distribute that, you have a highly distributed architecture, and this is something that you need for the application we're talking about. You need to do something for that link. So that and this is the whole point. So it's mobility management. Like if you try to distribute a lot, the UPF downstream the N9, how do you do that? That's the whole point. So today it's going to be GTP by default.
It is, but what I'm saying is that you still having a tunnel between on the N3, so that has to be whenever you have to move.
That's right. That's right. So
if you're saying that's really further out, then I mean somewhere probably that N3 is extended to that point. So
yeah, so it's not going to happen in one shot, and maybe it's not going to happen at all.
Yeah.
So the point is, these are the opportunities and what CT4 is discussing, and the point is how we can help in pushing innovation in different places to solve some of the issues and support some of the application we are talking about. It's not going to happen in all at once, for sure. Maybe it's not going to happen at all, but this is the path that we see already. Like we start with the N9, we propose something at 9, you see it works, it doesn't work. If it works, we can move to other interfaces as well. Well, let's go back to the questions.
What's a very quick question on the CT4 study? So is the purpose of that to just survey the different proposals, or will also be made some recommendation or selection at the end? Or?
My understanding is that CT4 is going to do 3GPP work. Like they get feedback from different sources, and DMM is providing feedback. They will take care about doing their own work, like analyzing the solutions, and acquiring knowledge from the different solutions. And the IETF will need to provide feedback about how the solution can address their own problems.
Okay.
But I think the subtext here is this is a really big opportunity. This is a huge opportunity. If we want to try to influence it, maybe we should step up our involvement in it. I mean, that's kind of what I'm reading between the lines. I don't know if that was what you meant. But
that's exactly what I mean. So there's an opportunity in general for, I would say, not only this research group, it's an opportunity in general for mobility management and the solution that can come from the IETF to have something different than GTP and provide real solutions for the problems of the application you mentioned, to have anchorless mobility, to offload the core, the mobile core. You put the constraints in the different requirements for the application we're talking about, which are not just video distribution. It's a lot more. Real-time communication, low latency. So, and there's an opportunity. So this is the whole point, like trying to catch that opportunity in the first place.
So one of the things that's entangled with the current tunneling architecture is the way authentication and authorization is done, because it assumes that you can transparently carry authentication and authorization information way back to some centralized place in order to let somebody onto the network. And if you, it seems like you can't just change away from that and not rethink authentication and authorization in at least some degree. And I didn't see that the 3GPP folks sort of like understand that.
I'm not sure I get 100% of the question, but I feel like, let me interpret your question.
Today, if your tunnel doesn't work, nothing works.
That's right.
Right? So that says they now exploit the tunnel to get you back somewhere where there's all this computing power and you've got your authorization databases and stuff like that, right? You get rid of that, you may still need to get all your data back to there, but then you can't survive. You can't have any local communication. You can't survive disaster scenarios. Often some of the low latency applications may need rapid startup as well as rapid operation. And then, so the latency of just getting started when you have to go all the way back into the core to do an authentication or authorization operation. I mean, I'm not sure I have an answer here. This is just a question. Are they actually thinking about this at all?
Now, the current study item is about a user plane only. So in this picture, for instance, you see the control plane and all the different policy control functions, which are currently not considered in the study item. So they are mostly focusing on the user plane, but what you said is absolutely necessary. So that means that this is coming back soon, probably, or maybe it's going to be a new thread very soon. But yes, the assumption is in this current study item, you don't touch the control plane. Control plane is unchanged. What are the solutions to replace the GTP and the user planes only? So the 5G service-based architecture makes use of a CAPS model, so where you have user plane and control plane separations. And the current study item is assuming that you don't touch the control plane, but just trying to replace the GTP protocol with other solutions for that specific interface or set of interfaces. But you're right. This is to be solved. Okay. So so a little bit faster probably. So the current solutions, the working group has been presented, and there is a draft that tried to collect the different solutions and classify them so that the reader can try to understand what are the options and the main contribution of each solutions to the different problems. So is a starting point, but the classification is essentially that we are trying to use is to have locator-based solutions, so basically GTP and evolution of GTP, even using locator-based solution like SRv6, and others using IDLock solutions. The well-known is Lisp, of course, which also support a control plane, which can be used for all the other user plane solutions like ILA and SRv6. So you see here SRv6 is being used as a solution for locator-based and IDLock solutions because for the flexibility that you can have in SRv6 for the different kind of semantics that SRv6 can carry. And this is one solution that can already enable some of the use cases we're talking about, where you basically you can offload the mobile core without going through the same SGW or PGW, for instance. So this is a first step toward offloading the core by a forwarding anchor. You still have, of course, the mapping system. So that means that you go through the mapping system to resolve the ID lock bindings, but it's a first step toward the use cases Yves mentioned. The third one, which is more related to the work done in this research group, is using ICN as a solution, purely ID-based. So, and when I say, so we have used in the working group the term ID-based, essentially to explain how we move in this classification from locator to ID lock separation and ID, where ID is a namespace, which is location independent. And HACN is the one that we have inserted in the document because it's using IPv6, and this is all the solutions are actually based on IPv6. So this is what is currently being proposed as a bunch of options that can be used, and CT4 can think about to solve some of their problems in the user space, in the user plane at least. Okay, I can skip this one. So this picture allows to understand where functions are located. So this is a typical mobile network deployment with the cell side access, backhaul, and core networks, and the upstream internet. So the whole point here is to be able to distribute these new user plane functions so that application can bypass as much as possible the mobile core when applications are local. So in like AR, VR, real-time communication, they are local and traffic stays local without going through the core. So this is an important set of applications where mobile edge compute plays an important role, and 5G is supposed to support this seamlessly. Maybe Jordan, you can come to show some of your animations. Yeah. Thank you.
Okay, so this slide is intended to show a bit how the different functions of the 5G architecture would be positioned in this mobile network. And so basically the data plane consists in the user, the UI, the user equipment, and you have the radio link that links it to the GNOT B. Then from there, you have the first N3 interface that connects to a set of user plane functions that are where the different processing is done. It's a generic function that can implement what was previously the SGW and the PGW. In a typical deployment, you would find two UPFs, one which is typically referred as the intermediate UPF, which was the SGW previously, which is optional in 5G, and another one which is the PDU session on core, and that's typically where the IP address and the prefixes of the UE are advertised to the internet. So of course in the spec you might have more than two UPFs, but we kept that for simplicity. And then you have the two control plane functions, which are the AMF, which is mainly responsible for the radio access, and the SMF, which is responsible for the session between the UE and the data network, DN. So one important feature that was introduced lately in 4G and then in 5G is the separation of control plane user plane, which allows to distribute some of these functionalities really close to the edge. I will skip this one. So in the DMM works, what has been proposed so far is two ways to try to introduce new data plane technologies. The first one is what is referred to the interworking model. And the idea is to propose new data planes without touching at all the 3GPP architecture and preserving GTP tunnels. So what can we do with it? And the second one is the integrated model, where we try to propose a replacement of the N9 interface. So N9, as Luca mentioned, is first considered because this is what CITES4 is responsible for and what has been asked to IETF. But further extension to N3, for example, would be interesting, and actually it's recommended in the draft for avoiding inter-networking. So N3 is linking the RAN with the mobile backhaul. So it's different working group. I think it's CT2 in 3GPP, which is responsible for that, and they would need cooperation if they want to extend this. So it's strongly recommended by the specification, because if you have two different technologies in N9 and N3, you need some internet-working between the two. So it's likely that a change in N3 will trigger more studies afterwards. Okay, and the integrated model is proposing the replacement of GTPU by those new data planes. So I will quickly show you some possibilities for the interworking model first. And there are two options. The first one is leveraging the mobile edge compute, and the second one is introducing some function in the UPFs. So one interesting function that we have in 5G is what is shown here as the ULCL. It's the ampli classifier. So it's a function, a UPF, that is able to split traffic based on some filter on the destination address. And that can be interesting to be able to divert some of the traffic towards some function which can be located in the MEC. So in this figure, you see from the ULCL, you have the standard path upstream going through the data network, but you have also a local breakout, which allows to early terminate the connection through another data network, which is situated in the edge network. And we could exploit this function to deploy, for example, an ACN node or a LocID node. And this is one of the proposals that allows to introduce some functionality early without disrupting any of the GTP tunnel. So in some way, you can introduce some functionality early in the network, but you get out of the 3GPP control plane, and that might not be ideal, although it allows to bring new functionalities easily. So the problem with such deployments is that when you get out of the network, you still have the IP anchor point, which is situated in the core network, and that would mean that any communication talking to the UE would have to go through this producer unless you do complex traffic engineering to try to redirect those prefixes. This morning we had a discussion that 3GPP would strongly advise to have a symmetric path, and that you would like the traffic to return back from where it exited the network. So second possibility would be insertion in a UPF. I will skip this one. And then the second option is to really try to leverage more the insertion of a new data plane by replacing GTP. Yes.
Just a quick question. I made that comment John made the comment in DMM2 about that symmetric routing.
Yes.
Does the ICN methods that you're proposing solve that in some sense?
So in hybrid ICN, we have the symmetry of the path. So you would ensure by design that the traffic comes back from where it exited, yes.
Is it because the user routes makes the request and hence it's symmetrical? Or there's more detail to it?
So what is ensured by HICN is that the traffics go through the rest path through each HICN node that was inserted, and we do that by using the rewriting of the source address of the packets that exit, so that when the node responds, it responds to the previous HICN hop, and this is done back to the requester.
Something like NAT? Maybe?
It's not a NAT. It's it can be similar. It's address translation.
X25. Okay.
Not helping.
I can take it offline. Discuss later.
Sure.
Thanks.
Okay, so
You can't have NAT if you don't have network addresses.
So the replacement of a 9 is really an alternative to GPU, and it's mainly replacing GTPU within the mobile backhaul between UPFs. So what has been proposed is to use either some IDLock implementation or ICN implementation at the different borders of the node, and use those new data planes to have a more optimized forwarding and mobility in between. So if we look at the protocol stack, so here we have represented the standard 3GPP protocol stack for 5G, and you see after the radio access, the GDPU stack, which is built on top of UDP IP. And one of the objectives would be also to try to simplify this encapsulation and eventually remove it. And that's why we have a solution like ILA, which tries to have to remove completely encapsulation and simplify mobility management. So we see that through these new data planes, we would be able to really simplify the protocol stack in between UPFs. And if you push this further, you can really remove completely the reliance on tunnels, and from the radio being able to directly have a simpler mobility management and completely anchorless communications. So I would stop there for this introduction, but I would be glad to answer any question you might have.
Yeah, first of all, thanks a lot for this introduction and overview. I think it's kind of important to understand for us also like the opportunities and the current developments in other groups. So we do have time for a question and discussion, so go ahead, please.
This is John again. Just a general comment. When you have this new data plane, I wonder, I've been exploring some ideas too around on the space that may use a distributed routing or something like that with gossip or so, and some way for it to converge. But it looks like if you're tracking per flow, if there are, the communications are going to be like an n square in terms of complexity. So I wonder if you've looked at the scalability and things like that.
So about which solution exactly are you referring to?
When you get to models where you're tracking flows per flow, then you end up with, if there are n nodes, and communicating with each other, you have an n square problem.
So, if I understand it right, you're assuming that you have per flow state in a ICN node to enable data plane communication. Is that right?
I am asking the question, can you avoid that in the ICN case?
Yes. I mean, we don't do that, so yes.
All right.
So I understand that so your current work is focused on hybrid ICN, so basically mapping the ICN semantics to IPv6 and TCP headers. Do you see also like opportunities for, say, direct, say, native ICN implementations or ICN as an overlay? So here this seems to...
Maybe. I don't know, but the current focus is on IPv6. So the answer is no if the focus is on IPv6. But the work that Ravi has been doing with other people here in the research group is using the. There's a very small opportunity to do that by using the so-called unstructured PDU in 5G, which is an opportunity to do that, but it's. If you look at the unstructured PDU specification in 3GPP documents, it's going to be 4 to 5 lines without any clear use case where you can really support the kind of approach. Mm. So I would say that maybe yes, but it's a probably longer term.
I mean, using even HICN, you're introducing 2 new primitives. Pretty much, you're saying there's an IP interest packet and IP data packet, and if you're doing some kind of network management, probably you eventually, if this sees the light of day, you would treat it as new kind of packets in the network. I would
new IP packets.
Yeah, I mean, but still, you introducing new functions into the IP layer. And I mean, you are overloading IP with some new semantics, and there are 2 new kinds of packets here with, of course, new transport semantics. And so eventually, I mean, it would be treated as some unstructured PDUs. I mean, because it's enabling new network architecture, and it has completely new definitions here. So.
The way HICN is designed, it doesn't require to use an unstructured PDU to be inserted.
It doesn't, but from a network management perspective, if you really are saying that, okay, I'm going to have this UPF with HICN features or in the say
okay,
IP
I get what your point.
Yeah.
So all the solutions for the user plane that I mentioned, with the exception of GTPU, requires what you just said.
I think GTPU is managed by the SMS.
That's right. The exception of GTPU because it's already there, but all the new ones,
yeah,
they require what you just said. Because, if, for instance, in the case of LIST, for instance, you need a mapping system. So in terms of
but I'm talking from an end-to-end perspective. You have this HICN application, pretty much ICN applications, right? I mean, they're just behaving like that, and they are now putting these new kinds of IP packets into the network, and you're enabling some new functions in the IP transport, saying that, okay, there are a few sets of routers that do HICN functions. So from network management perspective, you might want, I mean, eventually if people are going into the depth of it, they would like to separate these 2 kinds of PDUs, which are regular IP PDUs and the ones that are HICN based. So in that sense, what I'm saying, even when endpoints are putting these packets into your 5G network, they would probably want to treat it in a different way. It's a different, I don't know if that would go that way, but I'm saying that it seems to be a network management perspective that seems to be a problem by itself, right?
Yeah, network management in itself is a problem.
No, what I'm saying is that when you enable HICN features into the IPv6 data plane.
So the question is, what is a control plane or a management plane? How does it look like if you have a user plane with HICN? That's your question.
Yes. What I'm saying is that you've got 2 types of IP packets there, right? And it comes to John's question, it's still stateful forwarding. It's not, you're not doing stateless. You're doing stateful forwarding. And
so in the case of HICN, you need a control plane to fill the fibs, just like IP. So in that case, it's not going to change.
Yes.
So it's the same control plane. In the case of Lisp control plane, you need the Lisp control plane.
No, but Lisp is purely an encapsulation. It is IP in IP.
Okay,
so
encapsulation. I mean,
they don't need to. But
the encapsulation.
Having completely.
I don't think that the encapsulation is the whole point. The point is you have a new semantic in the user plane, which is loc ID. So encap or not is not a point because it can be made using ILA, which is not doing encap, but the philosophy is exactly the same. So that means that you need a Lisp control plane to enable the loc ID semantics in the user plane.
I'm not talking about Lisp. I'm talking about.
No, what I'm saying is that in all cases you need the insertion of a new management system for this new user plane solution.
In that case, I'm saying this new IP packets would have to be treated and probably would be treated in a different way.
So I don't think so. So let me see if I can try to bridge this discussion because you're talking across purposes. In any of these solutions that divert the traffic through a box that is going to do a different kind of routing and forwarding on the packets than the native oblivious IP forwarding would happen, either via an NCAP tunnel or via a NAT or via anything else, you are going to have the capability of managing those boxes and diagnosing problems with things that goes through those boxes, right? So I think we agree on that point, right?
Yeah.
Right. But from the point of view of anything else in the data path, there's no need to, and it's very dangerous to call these IPv6 packets different because they're not different. They're regular IPv6 packets. When they go through an IP router, the IP router cannot tell they're different.
Not from a.
And if the mobile, no, the reason I bring this up is this is the trap that the mobile operators fall into over and over and over again, which is something that's supposed to be general and transparent. They attempt, in many cases, to differentiate the different types of traffic and try to treat it differently. And every time they try to do this, they fall over, right? Because they create black holes. They try to accelerate things with proxies that slow things down. So I mean, whether you believe in this whole approach of trying to shoehorn ICN style routing, forwarding, naming into an IPv6 context or not, that's an interesting discussion. Some people think it's a great idea, some people don't. But the worst thing you could do is do that and then sacrifice the fact that you're using IPv6 in terms of it being transparent to everything that knows it, that only knows that it's doing IPv6.
I'm not talking vanilla. I'm talking about the perspective that these, particularly the nodes that are enabled with ICN, you are going to have them. I mean, you are carrying content in it. You're carrying interest in it. There are privacy issues there. So I'm just saying that it brings in completely different set of problems to.
Anyway, that would be great. I guess probably GDP will stay for a long time, but if we're going to have all those problems to solve, I'd be very happy.
No, I'm not trying to say that, but when you brought out the unstructured thing, I've just said that these flows might have to be treated differently.
John, again, a very quick follow-up question on that. You mentioned that you wouldn't end up with the n-square problem because you're not tracking per flow. And going on to what Dave said about authentication and authorization, would you be able to also authenticate and authorize users without tracking that state?
You have to. So that's a mandatory. I mean, it's not an option. Now, what I was saying, my answer was mainly the current study item is just focused on the user plane. It's not touching the control plane. That means that any solution has to support the user plane, the control plane functionalities as they are. That's the point.
User authorization by itself is not order n squared because you authorize users to talk to anything, right? So you only have one in. If you're attempting to do authorizations on a pairwise basis, this user is talking to this thing, then you have an order n squared problem, and we're back in hell, right? Forever.
That was the thing, that what goes on the N6 right now to the other end is the other end of so there's two parties in the control.
Yeah.
not going away for the moment. So thank you. Ken.
Are there any other questions? Or? So let me ask you. Let us one question. So thanks for introducing this to us. I mean, I know that you are kind of discussing this work in DMM and also in area and so on. Is there something that you kind of expect or would like to see happening in ICNRG? Something that the group should be doing, or any recommendations from your side? Or?
Research. Many of the things you mentioned, for instance, Eve, they are never presented at ICNRG, for instance. Maybe I'm wrong. Maybe Alicia can say something. But I would say the 90% of the papers or research work in the list, which is an impressive list you mentioned, have never been presented to the ICNRG, as far as I remember. So
I think that there might be another thing that we could help you with, and in fact, that was my question. How can we help? Because again, this is back to this whole point about here's this adjacent area for us to comprehend the nuances of all this is really hard. What we bring to the table, though, is the outsider's perspective. And so one of the things that, so I went to the DMM working group this morning and I was like, oh my gosh, there's only a certain percentage of it I understood. And I was, looking up acronyms and whatnot on the browser as I was sitting there. But what I thought I could do is review the document. And so, because my perspective is, fresh eyes, and I can sort of say what doesn't make sense. And then additionally, I think that there's, back to my previous comment about there's this opportunity. How do we advocate for, well, one, get these proposals into the kind of shape that we can rally around. Two, and there's actually an interesting point about that around timeliness, because the 3GPP community moves at breathtaking, very fast speeds, and we have to kind of keep up with them. But I think we can, once we get these proposals into shape and they represent our kind of community here that really wants to see something ICN-like out in the broader world, how do we strategically, I wouldn't call it infiltrate, but I would say influence, whether that means sending people to these working groups that are CT4, or whether it's coming at it from all these different working groups in the IETF or other kinds of standards bodies where we can have more of a presence. But again, we could talk about.
I think that especially for a research group like this one, my suggestion, how this research group can be useful, or in general, a research community on ICN, but in general, is providing data about this is useful. Because of we have a POC, we have software, we have simulations, and we run simulation. We showed scalability about this solution for that use case, for that application, and we see the data, and we can use that data to support one use case compared to another, and say this is where it's going to help, and we're going to gain X or Y, and the data is there, it's public, and we can use it. So this is typically the work I expect from research.
Okay.
And so,
well, maybe if you can keep us, for those folks who are involved in this bridging of the communities, keep us appraised of, continue to keep us appraised of the gaps and the places where they really need help. So if you could identify some places where you need help, maybe that could be a next step too.
Okay, thanks again. And we're now moving on with Akbar on deployment considerations.
So we're now into the draft updates section of the meeting. And I ask people to be efficient in their use of time. And also make sure you ask for whatever actions you want to have happen after this meeting on the list. Mm-hmm.
now. Push it up. The switch.
Oh, okay. Thank you. Okay, I'll try to keep it to my 5 minutes. So this is for the deployment considerations for ICN draft. I have some background material here, but more, you can read it offline. But basically, we're trying to address the charter item about giving guidelines for deployments, as the name suggests. Okay, so just a recap of what the draft covers. We basically first start with sort of a classification of the different types of deployments. I think more or less in line with the sort of research and industry view. There's the clean slate, overlay on top of IP, underlay, sort of basically being the basic fabric, and then as a slice, originally motivated by 5G, but could be applied elsewhere. And then in the last version, so I'll touch upon some of the latest updates we did as I talk. In the last version, we created this new category, composites, for any sort of system that doesn't cleanly fall into one of the other four. Sometimes, of course, even something that we classify as an overlay might have some characteristics from the other classes, but in general, most of the stuff could be cleanly classified. But then, of course, Luca and some other people brought up that hybrid ICN is something that doesn't really cleanly fall into any of the other categories. So we created this new category called composite, and as you can see from the next part of the slide, the hybrid ICN was really the one that as a trial that we could clearly categorize there. The other, so that was one major update since the last IETF, or since the last time I presented. The other major updates were basically in the ICN as an underlay. We got good feedback from the community about the NREN and the doctor test beds. So the NREN, my understanding is it's a US-based test system. So we got some good text there that from the participants of NREN. So we've put that into the draft. And then the doctor test bed, actually, we got a lot of good feedback from that group. That the doctor test bed is really it's concentrated on security. It's a French test bed. It's concentrated on looking at some security aspects of ICN. We've categorized it as an underlay, but it had also some virtualization aspects to it. It was basically coordinated sort of virtualized network reacting to security threats. So it had some aspects of ICN as a slice, but we agreed that it'd be classified as an ICN as an underlay. So really, this is one of the key parts of the draft. The other parts that did not have many updates in the last few revisions cover some other important aspects that we think are useful for people considering deployments. So we looked at, okay, what are the issues with application or service migration or migration of various parts of the network, and then we tried to map it back to those classes, and which class had which benefit for these issues that a practical operator or somebody else deploying would be considering. So that's what that deployment migration paths part of the draft covers. And then we had, for IETF and IRTF, an important section we thought for giving input to future standardization to help interoperability of ICN systems when they go into wide-scale deployments. So mapping to HTTP exchanges, dynamic naming, routing, etc. And then finally, we try to hopefully add some added value with some summaries. There was two main summary sections, one after the trial experience section, and then a final summary. So really just make a synthesis of all the key points, including in the last update, some, I think, good security considerations from the doctor testbed. This is small, but hopefully you can read it. It's basically the table of contents, so it gives you a good, view of what's covered. And then just in quick summary, we started the draft in Chicago. We got lots of interactive feedback. Dave also did a very good review, in that span between IETF 98 and 100. It got adopted in the 101 timeframe, and then the chairs suggested that we pull the working group to ask for more deployment trial experiences and any other feedback, obviously. And so revision 1, 2, and actually it's now revision 3. It's a typo, it's missing the 3. We got good input from these authors, they're not authors, but these contributors from different test systems. And Luca is here, I know. The other ones, Michael and Monsieur Doyen, I don't think they're here, but they gave good input. And really, next steps, is there any other trials that people think we should cover and that hopefully would add some added value, because we already have quite a good listing of trials. It's not meant to be exhaustive, obviously. It was more meant to be illustrative. And then to the chairs and to the working group, do you think going or seeing if we're ready for our RG last call is useful? From the author's point of view, we believe, if the document is of good quality, if people agree to that, it's probably better to put it in the RFCQ and have it as something published from the working group so that the community at large can reference it. So that was our thinking. So I'll stop there for any questions.
So questions for Akbar? So this document's had a nice contribution history and has moved quickly relative to some of the other stuff that's been going through this community. Let me just, we'll do the formal thing on the mailing list, but let me just get a quick hum in the room of people who have read the document. Who's any version? Okay, latest version. All right, so we kind of need some more eyes on this. There are two ways we could go forward. One is to plea for more eyes on it on the mailing list by itself, or the other is potentially call the question by trying to last call it, which is usually what brings out the additional comments. So let me get a sense, hum from the room. Are there people who think this is, should I state this negatively or positively? Is there anyone in the room who would look badly upon us trying to last call this document? Okay, so the chairs will take the action item of initiating an RG last call on this in the next few weeks once we decompress from this week. Again, now's the time to read it if you haven't yet. Right. So thank you very much. Chair's action is to do an RG last call. Thank you.
Okay. Thank you, Dave.
See, Milan is next. Milan, yeah. Here's the clicker. Thank you.
What am I missing? Doesn't work. It's possible because I think you sent us PowerPoint. Right? Yes. So that's running in Google Docs. Or you have to carry all the charts.
So hello, Milan Stolic with Cisco Systems. Worked on this draft together with Prakash Sutar, Anil Jangam, Dirk Trossen, and Ravi. This was about the native deployment of ICN in the mobility networks. Specifically, we were looking at the 4G or LTE. So the idea behind the draft was to as a reminder, to present a holistic view of native ICN deployments in 4G and LTE mobile networks. So we were looking at a few specific use cases depending on which of the nodes, if you think of the path between the UE and the gateways and beyond, depending on which of the nodes in that path do or do not support ICN. So we were analyzing first how would that look in the control plane, and then after that in the user plane, if you look at the path of the data packet, what would happen if the user equipment would be using dual stack, IP and ICN and native ICN deployment models. Similar thing for eNode B. And also in the EPC gateways, specifically for S gateway and P gateway, we are looking at the possibility if they support ICN, what kind of protocol changes we will be looking at, and we were discussing the introduction of the transport convergence layer in the protocol stack to support this. In the summary of draft updates, since the last time we presented this, that was back in London 4 months ago. So first of all, we want to thank the chairs and all of the reviewers for providing the input and making this a work group draft, and also the drafts we have, the draft updates we have implemented since the last time. Those were a few review comments. Then also regarding the QoS, which we vaguely mentioned in the first release, there was just a little more clarification on the definitions of the problem and the necessity of addressing them. This draft does not get into addressing the actual QoS implementation. That's beyond the scope of it. Then we also discussed the further CUPS implementation discussion. Basically, if the CUPS is implemented, what does that mean for the network? Then we described the lab setup, which we don't have the results yet, but the lab setup is in progress. And we paraphrased some of the text and updated and added new references. In a little more detail, so comment on the research done so far on QoS is what was added, and the necessity to handle QoS in data packets, and that's pretty much where we stop in this draft. When it comes to control and user plane separation, we were talking about the implication of the CUPS, if the CUPS were implemented in the network. What does that mean specifically to the publisher placement? How does that influence the publisher and its capabilities? A similar way was discussed for the UPF. If the CUPS is there, what capabilities are expected from UPF in order to accommodate CUPS, to accommodate ICN, sorry. And also an implication on the interworking gateway. Interworking gateway is introduced as a node in the case that, for example, P gateway in this case, or UPF do support ICN, but the final destination does not. So where it would have to be placed and what changes would be expected. As far as the lab, setup is in progress. Testbed diagram is in the new revision of the document, and the results are yet to come in the later release. For the future plans, we will want to have the results from the lab trials in the next release. So we plan on doing that for the next IETF conference. And areas for future updates that we are considering for updating are the further impact of CUPS introduction, because this was just touched on this time. Then also the realization of transport convergence layer that is mentioned on page 14 of the document. We would like to investigate further through lab trials and beyond. What does that mean really for the protocol stack? Impact analysis of ICN on mobility management messages, structure and flows, and also to investigate how the interworking gateway would react, or what would be required from interworking gateway to perform the conversion between ICN and IP primitives for data retrieval. Lastly, there's a number of ancillary functions in any data core, in any packet core, that would have to be analyzed in more detail if we were to introduce ICN to it. For example, lawful interception, billing, mediation, network slicing, provisioning APIs, requirements, and such. And that's all for the update so far. Thank you for your contributions, and we'll be looking forward to reviews and comments.
Thomas Schmidt, Harvey Hamburg. I have a suggestion. I guess I said that before. When you update the draft, could you sanitize and complete the references? Almost all of the informative references are incorrect, incomplete, and so on. That would be helpful.
Thank you, Thomas. I thought that was corrected. Apparently it wasn't. We'll look into it again. Okay. Thank you.
Okay.
So my chair hat's off for this particular comment. Could you go back to the previous slide for a second?
I can't.
Sorry.
Yeah. So the last bullet, just a piece of unsolicited advice.
Yes.
Tread carefully on any IETF document that talks about lawful interception, billing, or mediation. There are constraints on what we like to do in the IETF that touch on those things. Right. So we can give you some guidance on some of the previously published RFCs about IETF stuff, not getting involved in any of those things. So,
okay,
it's not that the document shouldn't have something; it's that you have to dance around the edges a little bit of what's acceptable to talk about for IETF work.
I understand. I may not be aware where exactly these edges are, so we'll have to get in touch offline.
It can be delicate, so we'll just work it through.
Understand. Thank you.
Right.
Thank you.
Okay, thank you, Milan. So we're moving on, and with Thomas. Give me a second. All right.
Yeah, so this is just a brief update on the ICN low-pan draft. Remember, the problem was we're looking at low-power lossy networks like 802.15.4 or similar. And wait a second, how is this? Is there?
No,
there's no.
Does it work or not?
I don't know. The question is, do you have a laser pointer here?
Yes.
Here, okay. So in the IP world, you have the 6 low-pan layer. If we put next to it the NDN or CCN layer, then these two can't interoperate anymore, and you will have a clash on the network. So for this, we already introduced in Singapore, I believe, the dispatch and fragmentation framework for a low-pan that jointly can operate IP and NDN or CCN. And we discussed first steps of header compression, and I will give you an update on this. So this is actually the point where we had an update. Whoops. So I have already presented, or Shink, I guess, presented in London about stateless header compression, where you basically take condense the TIVs to a more efficient format, and if you do so, you gain, for this example, it's just a simple example, you send an interest for this ACM, ICN, Boston, blah, 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 get a content of 21.2 degrees, and if you just do this for this simple example, you save about 25%. And what we introduced now is 2 stateful header compression mechanisms. One is a state local to the low-pan network, and the other one we called en route state. I'll show you in a second. So if you add these to it, then the compression results increase up to about more than half of the bits. So what is the local state? So what if you look in the document, or if you remember, there's this dispatch field, and this dispatch field, that's basically the compatibility layer in the low-pan that distinguishes between the payloads, and this dispatch field had an indicator bit on that you could have compression contexts. You could set compression context, and this is now defined here. You have a compression context that actually represents a shared state in the network. For instance, there could be a common prefix. It could be also stuff like interest lifetime or other things that are common to the entire network. Along the path or en route state is something that is specific for a particular request response, and actually goes back to an inspiration by Dave you gave in Singapore, if I remember correctly. And that is basically the idea that your request carries the name and the response carries the same name again. So what you can do is if you send your interest, you can distribute link local short identifiers and add them to the PIT. And that is basically done here. So you communicate your link local state. It is added to the PIT. And if you come back, then you simply communicate these link local states and you elide the name. So your data doesn't carry the name anymore. And that makes it just shorter. So that's basically it. The update was we did some homework on the NDN packet specification because that changed. We added the stateful compression and did quite a lot of editorial stuff. That's basically what changed the draft. And feedback welcome, of course.
Yeah, great work. Thanks. Any future plans that you would like to talk about?
Well, the next, basically what we want to do is we want to add stuff that is actually goes to other link layers like BLE and stuff, or LoRaWAN. That is not part of the draft yet, and probably do some more homework on the packet formats and on the details, and then probably will ask for a workgroup adoption or research group adoption soonish.
Cool. So currently there's one implementation of this. I assume that's yours. Yeah.
There is an implementation that is, there is a first demo on this, and I'm growing based on CCN Lite. Whoops.
Good. Thank you very much. Next is Jongha, update on the NRS drafts. Okay.
Yes, this is Jongha Hong from @3, and this is an update on NRS draft. I have a 3 draft which is related to name resolution service, and I'll go over the quick review of each and give the short update. And the first one is the requirement for NRS in ICN. This is the first revision, and this document discusses the motivation and requirements of NRS in ICN. And we presented a number of use cases in this draft. In this revision, we added another use case, manifest support for another use cases. The second draft is CCNX extension for NRS. This is our own NRS system, which is implemented based on CICN. And this describes the TLV-based CCNX messages for NRS, name resolution and name management. And also it describes the CCNX for the modification for NRS messages. And we have updated the description in details, but haven't changed much for the structures or contents of tables. And the last one is the architectural consideration of the ICN using NRS. This is the first revision. We just updated the introduction part as follows. The NRS has been discussed in ICN, focused on the considerations and requirements of NRS itself. And also there are a few NRS systems implemented, has been introduced in ICN. We had the Bluefit-based NRS system before for flat name-based routing, and now we have a CCNX extension for NRS. However, it is necessary to discuss the ICN architecture issues to be considered when another system is used or implemented in ICN. So this document discusses the ICN architecture considerations for NRS. And this was the short updates for 3 documents. And this is a summary of NRS talk that I presented in last Sunday meeting. As I just talked, we have implemented our own NRS system based on CICN, and we made our own NRS use cases, such as a file transfer for proof of concept and replica service with a video streaming, and produce mobility support with a live streaming service. And the first one, file transfer, was presented in Singapore meeting by a demo video. Also, last Sunday, I presented the produce mobility support by a demo video as well. And yeah, this is all I have today. And we have done a lot of work to make the NRS system as well as the use cases to support all the NRS draft for adoption to the working items. So please give us any comments for proceeding the documents.
Yes, thank you, Jongha. So, so the chairs have been, thinking about so what to do with this work. So as Jongha and colleagues have worked on this for quite some time, and it has been quite a journey. And so now they're at a state where they have achieved pretty good results, and for example, also shown in the demo on Sunday. And so name resolution sometimes comes up in our discussion, and so it's not only Jongha's team that's looking at that. So we are thinking about what would be a good output of ICNRG on this topic. And so Jongha has this 3 drafts that she just mentioned. Is there any immediate feedback or comment from the group? So do you think we should have a, say, published document on name solution at some point, or in the near future? Who else is working on name solution? I know there's NDNS, so I think that qualifies.
Take your chair hat off.
Yeah. Okay.
Chair hat off, Dave Oran, just a couple of thoughts. One is that, we as a research community are trying to capture the output of good work. And when we carry something forward, it's not necessarily saying this is the final answer or this is the right approach for everybody to take toward doing a particular function in the ICN world. So I'd like to sort of frame the question to the ICNRG, which is that there's a ton of work that's gone into this. Is the assessment of the group that it's mature enough to capture as publishable material out of the ICNRG? Because it's been done, there's a lot of work, we've talked about it a lot, if people think that it's valuable in informing our future work, whether this turns out to be the right way necessarily to design the architecture, there's a certain argument for pushing this forward toward publication. If people think that it's kind of a sideshow and maybe not something that will help us move other stuff forward, then you reach a slightly different conclusion. So I'd like to sort of frame the question in terms of the quality and the maturity of the work, as opposed to trying to come to some realization that NRS is the way to do particular things in the architecture, in contrast to doing them in other ways. So that's the way I'd recommend we frame this, with chair hat off. Right.
So before you came out here and spoke to us, my question back to the co-chairs and other people was going to be, well, what's the hesitancy? And if there is a hesitancy, because that was the way it was sort of asked, like we're hesitant. I don't know. That was just how I interpreted it. I would ask why, and could we frame some of the hesitancy as the intro to the documents so that we capture whatever the prevailing sentiment is in the proper language.
Well, so the consideration that I had was more that, I mean, there's now more than one draft, and so Junga started with kind of requirements, and so now lately they focused more on what we call architectural considerations. And so my question was more, so what type of output do we actually want to see? And so I agree to Dave that so when we publish something, we wouldn't really say, if you do ICN, you need to have an NRS and it has to look like this. It's probably more like this is the particular proposal that has been found useful in for example, Etri's work. But still, this shouldn't be, just say one person's activity should be coming from the group.
Yeah, I mean, routing on names is generally, I mean, it's a research challenge, and we had one draft which is looking into AI and I-split application identifiers and network identifiers that requires some kind of mapping system, and that fundamentally dictates how you do routing and mobility management and things like that. So I think that this is a very useful component function to investigate, but I would see it in that larger perspective of how do you handle name-based routing in ICN.
Okay, Börje Jonman, and this is also Chair Hartoff. I think, as Dave said, we have spent a lot of time discussing name resolution, and it's a topic that constantly come up and will most likely come up in the future also. So I think it would be good to have this documented in some way, and this is the best we currently have. So if people don't agree with what's in these documents, I would recommend them to step up and tell them why they don't like it or what they think should be added to them and so on, because I think it would be useful to have something to point back for next time the discussion comes up.
Yeah, thank you.
Okay, then so let's proceed as follows. So we're going to work on a proposal for proceeding and share this with you on the mail list, and so we hope to get some feedback from you. For now, thank you, Jonah.
Thank you.
Yep. So next is Dave proxying for Hitoshi.
Right. So I'm proxying for Hitoshi Eseda and Junshao from NICT and KIT. So there's a draft that discusses maybe one of the first attempts to really integrate network management types of functions into the ICN architecture, and deals with how you discover the state of content, routes, caches, and other things in an ICN network. So if we look back a little bit at the history, those of you who have been around probably recall this. This started out as one of two approaches to doing the equivalent of IP traceroute in an ICN world. And this proceeded in parallel with another draft called ICN traceroute that I may not be a co-author, but I contributed to. One of my PhD students, interns, did the work. And we sort of went off in a funny direction, said, well, maybe we can put these things together so we don't have two drafts. And after talking about it for a while and thinking pretty hard about it, we realized, no, we want to drive these things apart. We don't want to put them together because they're really doing different things. One is sort of like an in-band, very simple tool like IP traceroute, and the other one's a much sort of heavier weight but much more powerful hammer for instrumenting and debugging ICN networks. So it's been renamed CC Info, so it doesn't look like traceroute anymore. And it does a whole bunch of things. I don't want to go through them because this is a draft update, But it's a hefty draft, and I really recommend those people who haven't read it to read it. So it deals with things like reachability of publishers, reachability of caching routers, contents of caches, helps you compute popularity and cache hit ratio things. It doesn't actually carry it, but it helps you compute that. And a bunch of things that are really kind of potentially important in a production ICN network. So since the last time, there's a conflict between wanting to make one request and get back information from all over versus issuing individual requests and trying to steer them to gather the information you want. So we have sort of like a default and an option for how to do that. The multicasted version, which is option 2, has some very interesting congestion control challenges. So, I think that one's somewhat less mature and probably needs some more work. So from the last meeting, there were some questions that were brought up on the mailing list, and the current version of the draft pretty much gives those answers and addresses them. So here we are. We've split them apart. We have a substantive document that forms the basis for sort of baseline instrumentation and management capabilities. Works for CCN today, probably could be crafted to work for NDN if the authors want to do that. And I think we'd like to raise the question as to whether this is mature enough and of enough interest to the research group. And again, I have my chair hat off here to adopt it as an RG draft. So I'll turn it over to the other 2 chairs to sort of call the question there. Thank you.
Thanks, Dave. So who has read the draft? Okay. So I think more eyeballs would definitely be needed, but let's...
Yeah, a very short question, which is, remark first, question later. We need these kind of tools, especially now as an implementer of these kind of things. I feel like we are missing these kind of tools for a very long time, and it's kind of critical. So it would be really nice to have this adopted by the research group. And the other thing is, do you think these kind of things can also be worked out and adapted to use in HICN as well?
I'll let you answer that question. I don't see any reason why not. I mean, it's just another, in some sense, from a management perspective, HICN is another packet encoding of ICN semantics with some restricted namespace limitations.
Well, my question was, yeah, I know that it's possible. The question is, maybe the author would be willing to.
I think you'll have to ask the author, right? Okay. Yeah. So please raise it on.
If adopted, maybe
raise it on the list, right? Yeah. Make the proposal. That'd be great. My experience with Hitoshi and his collaborators is they're very, very amenable to input and help. So.
Right. So.
We can move fast because we need to do a wrap up. We have one more document.
Okay. So please read this document and contribute to the discussion on the mailing list. Okay. So next is Ravi.
Yeah, this is going to be short because the updates are not very significant this time compared to last time. So the basic goal of this, this basic goal of this draft is to basically look at deploying ICN considering the 5GC core network architecture that is being proposed in 3GPP. And, we have several motivations for this. Luca, Milan, and all referred to these in the context of these networks, flat architecture. We have receiver-oriented transport, storage, caching, seamless mobility, so on. The more important challenge is whether you could solve some of the problems related to the different use case scenarios for EMMB or MMTC or LCC in a better, effective way than what could be done using current kind of network functions. So the basic draft, what we do is to say that, okay, you want to have ICN endpoints and to have it introduced formally. So I'm not going to the architecture here, but you can read the drafts. It's very similar. It's basically we introduce ICN gateway in the user plane, and then we have some control functions to interact with the SMF so that you can do all the things like authentication and session management and all when you introduce ICN UAs. And one of the things we leverage is the use of unstructured PDUs. We had the discussion earlier, or what is non-IP PDUs for ICN deployment. And we have some use case scenarios. And we also have a paper that was presented a couple of weeks back at IEEE 5G. So this is the outline of the draft. So as I said, like we discuss the motivations, we look into the 5G core network architecture, and then propose certain extensions to it from the control plane perspective, user plane function perspective, and then it basically gives different use case scenarios for how this architecture could be useful. And we also kind of, though most initial versions were mostly looking from the CCN NDN kind of architectures perspective, but we also included discussions related to other ICN architectures that is working within this 5GC framework. The main updates in this draft is Greg who basically had a draft last time on IPOC, is basically looking at how IP services can benefit from ICN deployments. And since we had a section for basically native ICN support in 5G, so the work directly complements to what we are discussing. So he has contributed a bit to this draft. And then we have some another use case scenarios, what Dirk Trossen has been working on and looking into how his architecture, that is mostly what he calls IP over ICN, was demonstrated for basically supporting 5G control plane functions, again, within the context of this framework. So that's basically the draft updates. So again, this is mostly about, as I said, like at least in the context of 5G, we don't have another draft. So this becomes a good draft to take related contributions. If you have architectures that are looking into these frameworks or more research insights into, we actually in the draft, we have, like, particularly for native deployments, we have kind of listed several challenges of how you can handle things. And they did mention about all the other policy charging, but these are like important issues you cannot escape out in 3GPP. But all we are saying is that how can you do this in some novel ways in a more distributed context if you are doing something like ICN in 5G. So you see, the other thing is to, of course, see whether there is enough interest to take this as an RG item. There's good kind of industry participation in this draft, and I think it would be quite valuable to, considering that 5G is happening and you have release 16 and 17 happening. So it could be good, valuable inputs for those folks too.
So, quick question: who has read the latest version of this draft? Okay, good. Anyone wants to make a statement regarding adoption? Or?
This is Akbar. I think it would be something good to adopt. I did notice the previous discussion / debate, Ravi, that you had with Luca, and somehow, at least the topics seem to overlap somehow. So maybe one good thing, for the community point of view, would be to try to see if there could be some alignment, or I don't know if they were completely orthogonal. I don't think they are, but so in addition to supporting adoption as an RG item, that could be one area I would like to see maybe some improvement in.
Okay. Yeah, I mean, what Luca and team has been looking at, that's mostly from an IPv6 transport perspective. And this is mostly looking into kind of native ICN perspective. So the key thing is here, the main challenge is about you need the ICN function. Where do you place that ICN function? either, I mean, what the architecture says, you could place it in the RAN or you could place it crossing the IP tunnel. So, I mean, but here it's not really kind of, we are not overloading the IP semantics in any way. So ICN stack, there's a complete separation of what ICN does and what IP does. So we are not mixing those two worlds here. So, okay, thanks.
Okay, good.
Thank you, Ravi.
Let's follow up on the mailing list. Thank you, Ravi.
Yeah, thanks.
All right.
Sorry.
Okay, so wrapping up, we would just like to point you to some exciting events that are coming up. So in September, so that's going to be the RIOT Summit, September 13th and 14th in Amsterdam. RIOT is the IoT operating system that also has an ICN stack, and should be a pretty interesting event if you're interested in IoT. So there is an NDN community meeting September 19th to 20th. That's just the 2 days before the ACM ICN conference. So that is happening September 21st to 23rd, so Friday to Sunday. And then following that, we have a, what? So the program of that conference is going to be published pretty soon. If you still want to get involved, so just today we published the call for papers for demos and posters. Please check that. On the Monday after that conference, we are holding an ICNRG interim meeting, also in Boston. And just to let you know, I think there's also a network coding research group meeting on the Tuesday. So if you're in Boston anyway, you can extend your stay. Other than that, we are planning to meet in Bangkok again, probably also for Sunday interim. Let's discuss the details on the mailing list. Thanks again for coming and have a nice evening.
You can go to both meetings for the same price if you network code yourself. I didn't think we'd run to the last minute.
No,
and nobody really abused their time. They just used it. I have to go to the PRG.
Yeah, me too. I'm joining you.
PEA, not PEE.
Yes. P was supposed
Okay. It's much easier for everybody than having to go.